Hello and welcome to this 60-minute GCSE video. The idea here is to complete a whole GCSE exam paper, which is usually 90 minutes, in under 60 minutes. Today we're looking at the Edexcel June 2019 paper, which was actually taken on the 21st of May 2019. We're looking at paper 1 higher, and we're going to be doing a walkthrough. If you want to skip to a certain question throughout the paper, just click on the relevant chapter and it'll take you directly to the question that you need help with. If you do enjoy this video, do hit the like button and subscribe if you'd like more videos like this. The total number of marks is 80 and we have 90 minutes to complete the paper. So question 1. If there are only blue, red and yellow cubes in a box, the table shows the probabilities of taking a blue cube from the box. So the probability of a blue is 0.2, which means that the probability of red and yellow must add up to 1 take away 0.2, which is 0.8. The number of red cubes is the same as the number of yellow cubes. Okay, so that means that the probability of red must be the same as the probability of yellow. So we can write that down. Now we can say that the 0.2 add x, so if we add up all probabilities add up to 1. So that gives us 2x plus 0.2 equals 1. So 2x is 1 minus 0.2, which is 0.8, giving us x is 0.4. So we can replace that with 0.4 and that with 0.4. So the first question, complete the table, we're done. There are 12 blue cubes in the box. What I'll do is I'm going to add an extra row here for cubes. Now there are 12 blue cubes. Now if the probability of blue is 0.2 and red is 0.4, that's double, which means that there must be double the amount of red cubes as blue cubes. So there must be 24 red cubes. And the probability of yellow is the same as red, so there must also be 24 yellow cubes. So in total there are 12 plus 24 plus 24, which is 60 cubes. Number 2, Dion needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar and 2 times as much butter as sugar. Right, so there's a lot of information there. So the first thing I'm going to do is just make a note of some bits here. So in order to make 15 biscuits, I need 50 grams of sugar and 3 times as much flour as sugar. So that means 150 grams of flour. And 2 times as much butter as sugar, so 2 times that is 100 grams of butter. Now all of this is to make 15 biscuits. Dion is going to make 60 biscuits. So the first thing we need to figure out is, how do I get from 15 biscuits to 60 biscuits? Well, I've just got to multiply everything by 4. So the flour by 4, the sugar by 4, and the butter by 4. So how much sugar do we now need? We now need 50 times 4, 200 grams of sugar. How much flour? 150 times 4 is 600 grams of flour. And butter, 100 times 4 is 400 grams of butter. Now the question is, work out the amount of flour she needs. We've already worked it out here, it's 600 grams. So she needs 600 grams of flour. That's part A for 3 marks. Dion has to buy all the butter she needs to make 60 biscuits. She buys the butter in 250 gram packs. So how much butter does she need for 60 biscuits? Well, she needs 400 grams of butter. Now 1 pack will be 250 grams, which is not enough butter for the 60 biscuits. So 2 packs will be 500 grams, which is more than enough butter with a bit to spare. So the answer is 2 packs. Now it's always important with these types of questions, you always want to round upwards. Question 3, find the highest common factor of 72 and 90. So in order to find the highest common factor, we need to find the factors of each number. So the factors of 72 include 1 and 72, 2 and 36, 3 goes into it 24 times, 4 goes into it 18 times, 5 doesn't go, 6 goes into it 12 times, 7 doesn't go, 8 goes into it 9 times, and then 9 goes into it. So these are all the factors of 72. We do the same thing with the factors of 90. So 1 times 90, 2 times 45, 3 times 30, 4 doesn't go in, 5 times 18, 6 times 15, 7 doesn't go, 8 doesn't go, 9 goes in 10 times, and then 10 we've already got. So these are all the factors of 90. And what we're interested in is what's the highest common factor, so we can write the common factors. So I'm just going to circle these. So we've got 1 in common, we've got 2 in common, we've got 3 in common, we've got 6 in common, we've got 9 in common, we've got 18 in common, so we've got 18 in common. So these are all the common factors: 1, 2, 3, 6, 9, 18. So the HCF, the highest common factor, is the biggest number, which is 18. So that will get you your 2 marks. Question 4. The diagram shows a plan, front and elevation and side elevation of a solid shape drawn on a centimetre grid. In the space below, draw a sketch of the solid shape. Give dimensions of the solid on your shape. So first you've got to visualize this. If you're looking at this shape from the top, this is what you see, a circle. If you look at it from the front, you see this rectangle, and if you look at it from the side, you see this rectangle. What could the shape be? Well, if it's got a circular base, because we're looking at it from the top, this is going to be a cylinder. So you try your best to draw a cylinder. Use a ruler in your exam. So there's my cylinder. Now, because this is a centimetre square grid, I can see it's 5 centimetres tall. So I just need to mark out that it's 5 centimetres tall. I also can see that this circle has a diameter of 4. So I can mark either the diameter as 4, or I can mark out the radius as 2 centimetres. Okay, or if you want, you can mark both of them out. And that is all you need to do. So that will get you your 2 marks. Question number 5. Shape A can be transformed to shape B by a reflection in the x-axis followed by a translation of the vector CD. So first let's reflect it in the x-axis. So shape A, if we reflect in the x-axis, so imagine this is your mirror line. This point will now end up here. This point will now end up here. And this point, well, the difference from there to there is 3. So this is going to go 3 in that direction. So this is where shape A has been reflected to. Now this gets, let's call this A prime. Now this shape gets translated by the vector CD to get to here. So you pick a corner. I'm going to pick this right angle corner. So this one here. Okay, and the corner that we're trying to get to is the other right angle corner. So what's the vector to get from this one to this one? So we're starting from here, we're finishing here. Well, let's count. 1, 2, 3, 4, 5, 6. So I've counted 6, but I'm going to the left. So that must mean it's minus 6. And then we are going from here, we are going 1 down. So that's minus 1. So the vector I'm traveling is minus 6, minus 1. So the value of C is minus 6 and the value of D is minus 1. And that will get you your 3 marks. Question 6. A shop sells packs of black pens, red pens and green pens. Now there are 2 pens in each pack of black pens, 5 in each red pack and 6 in each green pack. On Monday, the number of packs of black pens to red pens to green pens was in the ratio of 7:3:4. A total of 212 pens were sold. All right, so this ratio is for the ratio of the number of packs. Number of packs. Okay, so that's black to red to green. So the number of packs of black to red to green are in the ratio of 7 to 3 to 4. But this question is not talking about the number of packs, it's talking about the number of pens. So we need a separate ratio to work out the number of pens. And the way we do this is, if you look at black, there were 7, the ratio of black pens is 7 black pens, but in each pack of black pens there are 2. So to find the number of pens, so if we're finding the ratio of black to red to green in the number of pens, we need to do 7 times 2, because each black pack contains 2 pens. The red pack, which there are 3 of, has 5 pens in each pack, so we do 3 times 5. And then the green pack contains 6, so that's going to be 4 times 6. So if we work these out, that gives us 14, 15 to 24. So that's now the correct ratio of the number of pens. Now what do these add up to? Well, 14 add 15 is 29. Add the 24 is 53. So this adds up to a total of 53 pens. Now we are told that a total of 212 pens were sold, so we need to get to 212. Now how do I get from this number to this number? I times by 4. So I times all of these numbers by 4, so 14 times 4 is 56, 15 times 4 is 60, and 24 times 4 is 96. The question is, work out the number of green pens sold. So that's 96. Okay, so just look out for what the question's asking you, because this question could have so easily just asked you, work out the number of packs of green pens sold, and in which case the answer would have been 96 divided by 6. Okay, but the answer to this is just 96 green pens. Question 7. Here are 2 rectangles. So you've got ABCD and you've got PQRS. And we've got some length. So QR is 10 centimeters and BC is equal to PQ. The perimeter of ABCD is 26 and the area of PQRS is 45. Okay, so I'm going to use this piece of information. If the area of PQRS is 45, then that must mean that the length of this, let's call it X, we can now work out, because the area of this triangle, the area of this rectangle, so rectangle PQRS is 10 times X, which we know is 45 centimeters squared. Therefore X is 4.5 centimeters. So we now know that this is 4.5, and we are told that BC and PQ are equal to each other. So this is 4.5 centimeters, which means that this is 4.5 centimeters. Now, since this is a rectangle, this is also 4.5 centimeters. Now we are told that the perimeter of this is 26. And since this is a rectangle, this length and this length are equal. So the perimeter of rectangle ABCD is y plus 4.5 plus y plus 4.5. And the perimeter adds up to 26 centimeters. This gives us 2y add 9 equals 26, which means that 2y is equal to 26 take away 9, 17, and y is 17 divided by 2, 8.5 centimeters. So find the length of AB. So length AB is y, so length AB equals 8.5 centimeters, and that will get you 4 marks. Work out an estimate for the value of the square root of 63.5 times 101.7. Now 63.5 is very close to the square number 64. So I'm going to round that to 64. So I'm going to say that this is approximately equal to the square root of 64 times, and then this is very close to the square number 100. which is the same as the square root of 64 times the square root of 100. And the square root of 64 is 8, the square root of 100 is 10, so your estimate is 80. So part B of the question tells us that 2.3 to the power of 6 is approximately equal to 148, correct to 3 significant figures. Now this question is asking us about 0.23 to the power of 6 to 3 significant figures. Now the connection you need to make here is that 2.3 is 0.23 multiplied by 10. Okay, now 0.23 times 10 is 2.3. So this to the power of 6 is equal to 148. This can now be rewritten as 0.23 to the power of 6 times 10 to the power of 6 equals 148. Now 10 to the power of 6 is a million. So this now becomes 0.23 to the power of 6 times 1 million equals 148. So 0.23 to the power of 6 is 148 divided by 1 million. And how do I work that out? Well, I can write down 148. Now the decimal point for 148 is here, and we need to move it 6 decimal places. So I'm just going to add in a few zeros. So 1, 2, 3, 4, 5, 6. So 0.23 to the power of 6 is equal to 0, and then the point goes here, and then we've got 1, 2, 3 zeros, 1, 4, 8. And it says give your answer to 3 significant figures, which we have. Question C, find the value of 5 to the power of minus 2. Well, that's the same as, so 5 to the power of minus 2 is the same as 1 over 5 to the power of 2, which is 1 over 25. And that will get you 1 mark. Question 9, work out 3.5 times 1 3/5. So the first thing we need to do here is write them both as improper fractions. So 3.5 times 1 3/5. So 3.5, 3 times 2 is 6, add 1 is 7 over 2, multiplied by 1 times 5 is 5, add 3 is 8 over 5. Top times top, 7 times 8 is 56, bottom times bottom is 2 times 5, 10, which is 28 over 5 if you divide both top and bottom by 2. This is an improper fraction. It says give your answer as a mixed number. So we can do 28 divided by 5, which gives us 5 with a remainder of 3, and then it's over this number here, 5. So your final answer is 5 3/5 for 3 marks. The graphs with the equations 3y plus 2x equals a half and 2y minus 3x equals minus 113 over 12 have been drawn on the grid below. Use the graphs to find the estimates of the simultaneous equations. Well, if this is one graph and this is the other graph, the solution is where the two of them meet. So it's that red dot there. So if we read off what that red dot is, it's that x value there, which I would say is 2.25, and read off the y value minus 1.4, and that will get you 2 marks. So let's have a look at question number 11 here. Bus company recorded the ages in years of the people on coach A and the people on coach B. Here are the ages of the people on coach A. So we've got 23 people, and we want to work out the median, the lower quartile and the upper quartile. The good news is it's already in order for you. So to find the median, we use the formula n, median is n plus 1 divided by 2. Now n is the number of people, which is 23, add 1 divided by 2, so that's 24 divided by 2 is 12. That doesn't mean the answer is 12, that means we're looking for the 12th person. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This here is the 12th person. The 12th person was age 59. Next we want to find the lower quartile. So the lower quartile, the formula for that is n plus 1 divided by 4. N is again 23, so 23 add 1 divided by 4 is 24 divided by 4, which is 6. So that's the sixth value. Now the sixth value, 1, 2, 3, 4, 5, 6 is 53. So your lower quartile is 53. And then your upper quartile, well, the good news about the upper quartile is because we know the lower quartile is the sixth value, the upper quartile will be the sixth value going backwards. So we just count backwards. So first, second, third, fourth, fifth, sixth. So 66 is our upper quartile. And that's our table, so that will be 2 marks. Here is some information about the ages of people on coach B. So we've got some data there. Richard says the people on coach A are younger than the people on coach B. Is Richard correct? Give a reason for your answer. So when you're comparing whether one is bigger or smaller than the other, what you need to look at is the median. So the median of coach B is 70, the median of coach A is 59. Is this true? Are the people on coach A younger? Yes, I would agree with that. Yes, as median of coach A is smaller. And that'll get you the mark. Final question. Richard says the people on coach A vary more in age than the people in coach B. So when we're talking about the how much the age varies, we can look at either the range or the interquartile range. You don't need to look at both unless it asks for 2 reasons. So we're just going to look at one of them, but we'll do both here. So let's look at the range. So the range of coach A is highest, take away lowest. So 79, take away 41, which is 38. What's the range of coach B? 85, take away 42. All right, let's see if this is true. The people in coach A vary more in age than coach B. Well, no. A has a smaller range, so no. A has a smaller range. And that's enough to get you the mark. But instead of doing the range, you could have also done the interquartile range. So I'll do this in a different color. So we can work out the interquartile range of A, which would be the upper quartile, take away the lower quartile, which is 66 minus 53, 13. And then the IQR for B, which is 73, take away 54, which is 19. Richard says that the people on coach A vary more in age. Well, again, the interquartile range of A is smaller. So again, you come to the same conclusion. No, A has a smaller IQR. And that will get you the mark. So you don't need to say both, you just need to say one of those 2 things. Question 12. Here are 3 spheres. The volume of sphere Q is 50% more than the volume of P, and R is 50% more than Q. Okay, so let's say that the volume of P is X. Now if Q is 50% more, then we're going to times that by 1.5. So this one will have a volume of 1.5x. And if this one is 50% more than that, then this one is 1.5 times 1.5x. Now 1.5 times 1.5 is 2.25x. So if the volume of P is called X, then the volume of R will be 2.25x. Find the volume of P as a fraction of R. So the volume of P is X, the volume of R is 2.25x. Now what we can do here is we can simplify this. So they have a common factor of X, so we can cancel them out. That would leave us with 1 over 2.25. Now we don't like to leave decimals within fractions, so what we will do is multiply through by 4. So we can multiply the top by 4 and the bottom by 4, because that 4 divided by 4 is 1, so we're not changing the value. 1 times 4 is 4, 2.25 times 4 is 9, and that's my answer, 4 over 9. Given that n can be any integer such that n is greater than 1, prove that n squared minus n is never an odd number. So there's a couple of ways you can prove this. Now for GCSE, for 2 marks, you don't have to use algebra. We can say we can come up with the two different scenarios. So for example, if n is odd would be our first scenario, and in our second scenario n is even. So if n is odd, then we've got n squared. Now an odd number times an odd number will always be an odd number. Okay, so if n is odd, we end up with an odd number, take away n. Now n was odd as well. And an odd number take away an odd number will always give you an even number. Now if n is even, then we do an even number squared. Even number times even will be even. Take away n. Now n is odd, so take away, sorry, n is even, so take away an even number. And if we take away two even numbers, we will always end up with an even number. So prove that it's never an odd number. We've just done that because if n is odd, we're going to get an even answer, and if n is even, we're going to get an even answer. So that's done. Question 14. Find the exact value of tan 30 times tan 60. Give your answer in its simplest form. So to answer this question, you need to understand exact trig values. So I've done a whole video on exact trig values. You'll find the link for that in the description below, so feel free to check that out. But you should know the value of tan 30 and tan 60. So tan 30 is equal to 1 over the square root of 3, and sine 60 is equal to root 3 over 2. So if we multiply these together, tan 30 times sine 60, we get 1 over root 3 times root 3 over 2, which is root 3 over 2 root 3. Root 3's can cancel, leaving us with 1 over 2 1/2. And that will get you your 2 marks. So now we're beginning to get to the tricky part of the exam paper. Question number 15. The diagram shows a solid shape. The shape is a cone on top of a hemisphere. Now a hemisphere is basically half of a sphere. I've just had to rewrite these formulas because we had some formatting errors there. So the volume of a cone is 1/3 pi r squared h, and the volume of a sphere is 4/3 pi r cubed. So we need to work out the total volume of the shape and give it in the form k times pi. So we need to leave it in terms of pi, which is good because we are in a non-calculator paper. So the first thing we will do is write down the volume of a cone formula, which is 1/3 pi r squared times h, which is 1/3 pi times r. Now r is the radius of this cone. So the radius of this cone, well, if the diameter is 6, the radius will be 3. So pi times 3 squared times 10. 3 squared is 9, times 1/3 is 3, times 10 is 30, 30 pi. So the volume of a cone is 30 pi. The volume of a hemisphere. Now a hemisphere is half of a sphere. So the formula for the volume of a sphere will always be given if you need to work out the volume of a sphere or a hemisphere. All we do is we halve this formula, so 4/3 becomes 2/3. So 2/3 pi r cubed. And if we substitute in our values, so 2/3 pi, now r is the radius of this sphere, which is basically a distance from there to there, which is also 3 centimeters. So r is still 3, so 2/3 pi times 3 cubed. Now 3 cubed is 27. We divide that by 3, which is 9, times that by 2, which is 18, giving us 18 pi. So to find our total volume, we add up these two answers. So the total volume is 30 plus 18 pi, so 30 pi add 18 pi, which is 48 pi. Now just make sure you read the question. The question says work out the value of k. So this is in the form of k times pi, so k is therefore 48. And that's how you do that one. So this next question is about the combinations on a numerical padlock. So we have 3 digits such as 5, 5, 3. Each dial can be set to any of the numbers 1 to 5. So 553 is one of the ways it can be set. Work out the number of different 3-digit numbers that can be set for a combination put the combination lock. So we have 3 different numbers. So that's your first one, that's your second one, and that there is your third one. Now this first number could be any number between 1 and 5. So there are 5 ways for that first number. This second digit can be any number between 1 and 5. So there are 5 different digits that could be. And this third one could be any number between 1 and 5. So there's 5 ways that we can have that number. So to find out the total number of combinations, all we do is we multiply these together. 5 times 5 times 5, giving you 125 different ways. Question B. How many of the possible 3-digit numbers have 3 different digits? So that means 553 would not be allowed because we don't have 3 different digits. So we can start off the question in the same way, but we just need to think about it a bit differently. So we've got 3 digits. Now this first number could be any digit between 1 and 5. So there are 5 ways to do that. Now the second digit, do we have 5 ways to do that? Not quite, because we need to have 3 different digits. So we can't have the digit that we had there, no matter what that digit was. So instead of 5 ways of having this digit, there's only 4 ways that 4 different numbers that this could be. Right? So if we had a 3 there, then we're not allowed a 3 there. If we had a 2 there, this number's not allowed to be a 2. So there's going to be one less thing that we can have there, one less number that we can have for the second one. And now for the third number, this third number has to be different to this number and to this number. So instead of 5 ways for this one, there's going to be 3 ways for this one. And all we do is we multiply them together, giving us 5 times 4, which is 20, plus times 3, which is 60. So there are 60 ways of doing this with 3 different digits. Question 17. X squared, the ratio of x squared to 3x plus 5 is equal to 1 to 2. Find the possible values of x. So we're looking at equivalent ratios. Now whenever you've got equivalent ratios, you want to convert these ratios into fractions. So the way you do that is x squared to 3x plus 5 simply becomes x squared over 3x plus 5. The ratio 1 to 2 becomes 1 over 2, and there's an equal sign there, so we make them equal to each other. So now we've got this fraction equal to this fraction. So what we can do now is we can do cross multiplication. The top of that times the bottom of that gives you 2x squared. And then the bottom of this times the top of this gives you 3x plus 5, and we can make them equal to each other. Now if we take everything over to the left hand side, 2x squared minus 3x minus 5 equals 0. We now have a quadratic equation. Because it's a non-calculator paper, it's likely to factorize, so I would always try that first. So in order to get 2x squared, we need a 2x and an x. In order to get the 5, we're going to have a 1 and a 5, and it's just a matter of thinking about where do I put the 1 and where do I put the 5. So let's put the 5 there and the 1 there, and I need it to be a minus 3x. So minus 5 plus 1. And if we mentally just multiply that out, 2x times x is 2x squared. 2x times 1 is plus 2x. Minus 5 times x is minus 5x. So 2x minus 5x is minus 3x. And minus 5 times 1 is minus 5. This times this is equal to 0, which means that 2x minus 5 equals 0, or x plus 1 equals 0. So 2x equals 5 and x equals 5 over 2. And on this side, x, take the 1 across, x equals 0, take away 1, minus 1. So your possible values of x are x equals minus 1 or x equals 5 over 2. Number 18. Express root 3 plus root 12 in the form of a root 3 where a is an integer. So this is simplifying surds. So we can rewrite this as root, we'll keep that as root 3, and then root 12 can be split into 2 numbers. The first number must be a square number. So what 2 numbers times together to make 12, where the first number is a square number? Well, that would be 4 times 3. And there's also a clue that the second one has to be root 3. We simplify this, so this becomes root 3 plus, and then the square root of 4 is 2. So it's root 3 plus 2 root 3. If you want, you can stick a 1 there. So 1 root 3 plus 2 root 3 gives you a final answer of 3 root 3, and that will get you 2 marks. Question B. Express 1 over root 3 to the power of 7 in the form root b over c, where b and c are integers. Alright, so 1 over root 3 to the power of 7 can be rewritten as 1 to the power of 7 over root 3 to the power of 7. Right, so this is equal to 1 over root 3 times 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 root 3. Now, we can begin to group some of these together, because root 3 times root 3 is 3. This root 3 times root 3 is 3. This one is also 3. So now we can simplify this as 1 over 3 times 3 times 3 root 3. And 3 times 3 times 3 is 27. So it's 1 over 27 root 3. So that's our answer. Is it in the correct form? No. We need to rationalize our denominator. So to do so, we need to multiply by root 3 over root 3. We're allowed to do that because that's equal to 1. We do top times top, which gives us root 3. And then we do bottom times bottom. So we get 27 times root 3, which is root 9. And root 9 is 3. So our final answer is root 3 over 27 times 3, 81, which is in the correct form. Question 19. Given that x squared minus 6x plus 1 can be written in that form for all values of x, find the value of a and b. So hopefully from the question you realize that this is asking you to complete the square. So we complete the square, we have an x, we have a minus here, so we have a minus in our bracket. We halve this number, so half of 6 is 3, stick a squared in, and then we're going to minus this number squared, and then we're going to add the 1. And this will give us x minus 3 squared, take away, and then minus 3 squared is 9, add 1. Which can be simplified to x minus 3 squared minus 8. So now, what do we have? We need to give it in this form. So what's the value of a? Now a is that number there. So it's x take away a, and this says x take away 3. So a is equal to 3. And then we have a minus b, we have a minus 8. So our b is equal to 8. And that's the first part of the question. Hence, write down the coordinates of the turning point of the graph. So the turning point is either a maximum or a minimum. In order to find the turning point, you make the value of the bracket equal 0. So if I rewrite the answer from earlier, so what value of x would make the bracket equal 0? So the value of x that would make the bracket equal 0 is positive 3. And if x was equal to positive 3, what would this whole thing equal? Well, 3 take away 3 is 0, 0 squared is 0, take away 8 is minus 8. So your coordinates will be 3 minus 8. Question 20. H is inversely proportional to p and p is directly proportional to the square root of t. Given these values, find a formula for h in terms of t. Okay, so let's break it down line by line. So let's take this first line here. H is inversely proportional to p. So we can rewrite that as h is inversely proportional. That means just 1 over p. And then we can replace this with an equals k. So h equals k multiplied by 1 over p, which I can rewrite as k over p. We can substitute in some values. So h is 10 equals k divided by p, which is 6. Therefore, k equals 60. Okay, so k is equal to 60, and if we substitute that back into this line, we come up with h is equal to 60 divided by p. So that's our first bit. Next, let's look at the second piece of information that we've got is p is directly proportional to the square root of t. So p is proportional to the square root of t. That means that p is equal to k times the square root of t. Now, since we used k already, we should use a different letter. So let's use c instead. C times the square root of t. Then we substitute in our values. So p is 6. So 6 is equal to c times the square root of t, which is 144. Square root of 144 is 12, so that's 12c. So 6 equals 12c, so c is equal to 6 divided by 12, which is a half. Substitute that back into there. We get the equation p is equal to half square root of t. Now we put these together because we need a formula for h in terms of t. That means h equals something. So we can start with this. H equals 60 over p. And then we can replace p with this. So giving us 60 over a half square root t. And then we can rewrite that as 60 divided by a half is 60 times 2. So it's 120 over the square root of t. So h is equal to 120 divided by the square root of t, and that's my formula for h in terms of t. Functions f and g are such that fx is equal to 3x minus 1 and g of x is equal to x squared plus 4. Find f to the minus 1 of x. Alright, so before we even look at this question, let's just talk about what each function does. What does function x do to its input? It trebles the input and then subtracts 1. So it multiplies it by 3 and then you take away 1. What does function g do to its input? It squares whatever you put inside and then adds 4 to it. So let's answer the question now. So find f to the minus 1 of x. That means find the inverse of function f. So what we will do is we'll copy out function f, which is fx equals 3x minus 1. We'll change that into y equals 3x minus 1. Now the trick here is you change all the x's into y's and all the y's into x's. So this becomes x equals 3y take away 1. And now we make y the subject. So if we take the 1 across, we get x plus 1 equals 3y. And then to get y, we just need to divide both sides by 3. So it becomes x plus 1 over 3 equals y. So our answer is x plus 1 over 3, so we can just write f to the minus 1 of x is equal to, let's write the whole thing here, f to the minus 1 of x is equal to x plus 1 over 3. And that will get you your 2 marks. Given that fg of x is equal to 2g f of x, show this. So this is talking about composite functions. So fg of x, now the way I like to teach this is if you've got a composite function like this, I would rewrite it as f, then a square bracket, then g of x normally, and then close the square bracket. So by writing it like that, we know exactly what we need to do first. So from here we can clearly see that the g of x needs to go in first. Well, g of x can simply be replaced by x squared plus 4. So this now becomes f of x squared plus 4. Now we need to apply function f to the input of x squared plus 4. Let's remind ourselves, what does function f do to the input? It multiplies it by 3 and then subtracts 1. So our input here is x squared plus 4. So we're going to multiply x squared plus 4 times 3, and then we're going to take away 1. So this equals 3x squared plus 12 minus 1. So that's 3x squared plus 11. Okay, so that's the left hand side of that. Now let's look at the right hand side. We'll use a different color. So 2gfx. So 2gfx, again we're going to write this as 2g and then square bracket fx. So the 2 just means we multiply by 2. So 2g and then f of x is what we need to do first. So f of x is 3x minus 1, so we're just going to write 3x minus 1. So what's g of 3x minus 1? Well, what does g do to its input? It multiplies the input by itself, so x squared, and then adds 4. So we square the input and add 4. So this is going to be 2, and then we're going to square the input, which is 3x minus 1, and then we're going to add 4. And then afterwards we need to multiply through by the 2. So that's now going to give us 2 And if we multiply all of this out, this will give us 9x squared minus 3x minus 3x plus 1. That's from that, and then add 4, which is 2, and then 9x squared minus 6x plus 5, and then multiply that whole thing by 2, 18x squared minus 12x plus 10. So this is 2gf of x, which is that. So now we are told that fg of x is equal to 2gf of x. So all we need to do is make them equal to each other, and that should be it. So if we write that is equal to that, so 3x squared plus 11 equals 18x squared minus 12x plus 10, and I need to get a 15x squared. So let's bring everything to the right here. So if we move this across, then this will become 18x squared take away 3x squared, which will be 15x squared, and we move this 11 across, so the minus 12x remains as it is, and then this 11 becomes a minus 11, so 10 take away 11 gives you minus 1, and that equals 0. So that's what we've got. So we've answered the question. Notice that here you do not need to go on and solve this. The question is just show that it's equal to that. So don't waste time trying to solve it, because the question is not asking you to do so. And that will get you full marks. Question number 22. This is the final question in the paper. So there are R red counters and G green counters in a bag. A counter is taken at random. The probability that the counter is green is 3/7, and the probability that the counter is put back into the bag. Then 2 more red counters and 3 more green counters are put into the bag, and then a counter is taken from the bag. The probability of a green is now 6/13. Find the number of red and the number of green originally. Okay, so let's work out the probability of green from the start. So the probability of green from the start is equal to the number of green counters in the bag, which is G, divided by the total number of counters in the bag, which is the number of red plus the number of green, so R plus G. So that's the probability of picking a green, and we are told that this is equal to 3/7. So from here, we've got a fraction equals a fraction, so we can cross multiply here. So if we cross multiply, G times 7 gives you 7G, and that times that gives you 3R plus 3G, and we can make them equal to each other. So we have an equation. The problem with this equation is we have 2 unknowns. So let's read on. So 2 more red counters and 3 more green counters are put in the bag. A counter is now taken at random from the bag. Find the probability that the counter is green. So let's try this again. So now the probability of green now is the number of green counters, which is, so we picked a counter, we put it back in the bag, so we still have the same number of counters to start off with. We add 2 more red and 3 more green. So the number of green now is green plus 3. So there's 3 more greens. And then the total number of counters is the original, which was R plus G. And then we've added 2 red and 3 green. So there's 5 more counters in the bag. And this is equal to 6/13. And again, we have a fraction equals a fraction, so we can do some cross multiplication. So this times this gives you 13G plus 39. And then this times this gives you 6R plus 6G plus 30. And that gives us a second equation. So now that we have 2 equations, we also have 2 unknowns. We should now be able to solve, because the question is asking us to work out the number of red counters and green counters originally in the bag. So let's see what we can do. So from this equation here, if we take the 3G to the left, we get 4G is equal to 3R. And for this equation here, what we can do is we can take the 6g to the left, giving us 7g. So 13g take away 6g is 7g. And we've got a 6r here. And then this 39, if we take that to the right, it becomes 30 take away 39, which is minus 9. So we now have 7g is equal to 6r minus 9. Now over here we have 3r, over here we have 6r. So let's double this equation. So if we double this equation, write it down underneath, 4g times 2 is 8g, 3r times 2 is 6r. We now have these two equations, and all we need to do is subtract them. So if we do 8g take away 7g, that leaves us with a 1g, and then 6r take away 6r, they cancel each other out, and then 0 take away minus 9 leaves you with plus 9. So we've now got g is equal to 9. If we now substitute g equals 9 into this equation here, we get 4 times 9 equals 3r. So 36 equals 3r. So r is equal to 36 divided by 3, which is 12. So the number of red counters was originally 12, the number of green counters was originally 9, and that will get you full marks. Thank you for watching the exam paper walkthrough for this exam paper. If you did like the video, do hit the like button and subscribe if you'd like me to do more of these. And if you didn't already know, we have a TikTok channel. The TikTok address is @Mathinar UK, and on that TikTok account we post daily maths videos which can help you with your revision. So do check that out if you haven't already done so. See you next time.